to definitely share with you something I've added to class. Now, I added today this document right here, CE Credits AUG 2022. We're going to go over it. So, but it's here for you to reference in case you need to reference it after we go over it today. So what is this? Well, here's the great news for you. How many of you are in your 3-year period when your CCNA is valid right now? Okay, when does your CCNA expire, John?
I don't know.
Is it before June of this year?
No, it'd be like August, I think, of this year.
All right, well, I got good news for you. Okay, this class will renew your CCNA.
Whoa.
Yep.
Wow, really?
Yeah, what Cisco has done is they have a program now, and this has been true for a while. Most people just didn't know about it, but they've had a program called CE, or Continuing Education Renewal, for your Cisco certifications. So your certifications are able to be renewed if you do CE. Now, a couple ways to get this CE is, one is going to Cisco Live and spending a lot of money to be in their paid for events, and yeah, which is, I love Cisco Live, don't get me wrong, I'm going, but we got a better way for you. So you're going to be able to, with approved activities, earn credits and be recertified. All right.
Wow, that's perfect. Oh my gosh.
So here's what you got to do. If you are going to renew your associate level certification, you've got to earn 30 CEs. 30, and these CEs are not Stanley Community College CEs. These are not any other type of CEUs that you get from your job. These are only things approved by Cisco and Cisco certification. And I will tell you, Cisco certification and Cisco Networking Academy are two totally different entities, and they don't always talk to each other. This has been one of the few times they've been able to work together nicely, which is good for all of us. Okay, so these are the number of hours you need to renew your certifications. NetAcad has these classes that are available to give you CEs. If you take and pass CyberOps Associate, you can earn 30 credits. DevNet, 40. This course, this should show you how hard this course is. This course earns you 64 CEs. That's why this class is stupid. I mean, it's that hard. But the important thing here is this: from the time when you finish this class, you have a maximum of 90 days to get in this information to the continuing education portal. I'm going to show you where that's at. I'm going to show you how to do it, but it's your job to do it once I finish you and you complete this course. All right. If you don't submit it, you won't get credit. There's no way for us to go back. There's no, if you don't do it, you're out of luck. Okay, this is one of those things, if you don't apply for it, you will not get an extension or anything of that nature, because already we're kind of lucky they're letting us do this. So, but if you're in the middle of trying to get your certification, you've had it for a year, if you do this now, it would extend it for 3 more years. If it's at the end of your 3 years, it'll extend it for however long, for 3 more years. Okay. They must be submitted before your certification expires and approved. So don't wait till the last minute. If it expires in August, get it in right after this class ends in May. All right. As soon as I get you accredited. So here's the CE portal, ce.cisco.com. You will notice the item name, date, those things are all there. You'll be able to submit items. And in that, you will select what it is. So for us, it'll be CCNP Encore. You will select your provider, which will be Network Academy, and the type of training will be Network Academy training. And then start and completion dates will match the class dates. You can get that by looking in NetAcad. Okay, so inside of NetAcad, if you look at the course has start and end dates. So this class has a start date of 8th of February and end date of 19th of May. So it's right here. It's on your listing in your class under your I'm Learning tab. Okay. So you put that in, Requests are processed in 7 to 14 days. So don't wait till close to your end date. Otherwise, you get in trouble. So must be submitted before the expiration date. That's it. That's how simple it is, folks. You finish this class, I accredit you, you submit it, your certification should be renewed because of the fact that you're getting 64 credits. You'll notice again, it only takes 30 credits for an associate. It only takes 40 credits for a specialist. 80 for a professional. So if you're in a professional, like if you got CCNP, if you took this exam, you couldn't take this class and get enough credits to renew it, but you can take this class in DevNet and you can do it. Okay. Any questions on this? Because this is a huge bonus for you. If you need to, even if you've got your CCNA and it's good for another 2 years, go ahead and do it because it's going to extend it another year.
So I do have a question. I'm about to renew my CCNA. Unfortunately, expired in December.
Okay.
If I do pass it and I before this course ends, how will the credits help me in that case? Because then I have the CCNA valid for 3 years.
Yeah, it's not really going to help you. No. If you'd have taken it before it expired last December, you'd be in golden, but unfortunately, no, it's not really going to help you.
Okay.
You can still use it. Here's the good news is you can still use this as just CEUs for your own professional development. I mean, the good news is Stanley Community College gives you 8 CEUs because this is an 80-hour course. You actually can print an 8 CEU certificate of completion from Stanley's website when you get done with this class if you finish successfully. So it will help you in that terms. But as far as Cisco is concerned, they only give you 64 credits of their official CEUs for renewal.
All right. Thanks.
I can't say enough how important it is to use this because it is you have to pay any money for renewing? No, you don't have to pay any money. So what log on, Nicholas? That page that I gave you, the CE, I think you have to be logged into NetAcad. Let's see, control, select it.
Yeah, it's I use my NetAcad login, and once it lets me log in, but then it says I'm not authorized beyond that point.
Oh, okay. If that continues, I can let me see. Is your NetAcad account and your testing account different? That is always a possibility.
More than likely, yes, because I don't want my I don't want my .edu account attached to my certifications.
See, this is what I get. So I've got it. So basically continuing education program. So if I get it.
It did not prompt me for
So yeah.
the EULA and that stuff like that.
So I've got 818 days until mine expires. Whoop, whoop. No, I'm just kidding. I would say more than likely that's the reasoning. It's because you are you don't have your NetAcad account and your others together. You need to find a way to get those two matching up because you only want one account. So my Cisco ID and all is the same as all those. Now you don't have to have your EDU email address associated with your Cisco account. Mine is, but you can change your account.
I gotcha.
You can change your NetAcad account by going to your profile. Just go into your profile and change your email address associated with it to the same one associated with your certification, and I bet that'll fix it.
Okay, because I thought that we were like locked into our domain because like I'm the academic manager on the Cisco site for our school, and so I thought it had to be a .edu.
Nope, it does not. In fact, my one of my ITC instructors has his own personal email address. It's his Cisco NetAcad account email. The important thing is this, and most people know this, but the important thing is that the email address is actually the most important part of the account. That's what keeps all the accounts unique, is your email address. So I would try doing that. I would try changing it to the same as what's on your certification account, and then see if that won't work for you. If not, we'll do some investigation and figure out how to make it happen.
Gotcha. Yeah, I'll give it a shot this week and we'll see how that goes. Thank you.
Yeah. No problem. For me, I log right in and I can apply. I mean, I'm able to apply items if I want to. So, but
And Kelly, for me, my CCNA doesn't expire until next year. So would I get a 2-year extension?
I think it extends it for 3. I think
Okay.
that's how it works. I think when and I'll have to do some looking into that, but I'm pretty sure it adds 3 years to it. Yeah, I'm pretty sure that's how it works. So I'll do a little more looking into it, but I know it definitely renews it. If it doesn't, it has to renew it for 3 more years. So it gives
Okay.
it full renewal.
I don't mind being a guinea pig. I'll let you know
Yeah.
what it looks like on my side too.
Yeah, definitely. But I'm almost certain that it does. This came out, what was it, about 2 or 3 years ago, they came out with this CE program. I think it was, they actually announced it at Cisco Live a couple years ago, so that you could get credit for it. So, but yeah, here's a page on it that I'll drop in the chat so y'all can all look at it too. It's a page that's got a lot of information about the additional. So CE policy. So like I said, you can do Cisco Live technical sessions. These typically cost a fortune. But some of them don't. Like some of these 100 level sessions you can go to for free and you get a credit per session. And then some of them you can get a large amount of sessions for it. But so you also can actually author exam items for them if they want to, but so it's pretty neat. Pretty good little thing that they've been able to get for everybody. Okay. Any questions on that? I placed again inside of our class on Canvas this CE credit, so you've got it right there with the links and everything you need to go make it happen. So just be aware of that. The other item I want to talk about, I want to show you this so that you're all not freaking out. Okay. Let's look at our routing protocol section here. Look at what is actually listed for BGP. Configure and verify eBGP between directly connected neighbors, best path selection, algorithm, and neighbor relationships. Now, folks, that is a long way from this right here, which is when we look at CCNP, okay? So I look at my CCNP and we look at this, that is a long ways from multi-protocol BGP, BGP path, BGP communities. This lab 1112 is really the lab that covers what's on this blueprint. Now, does that mean you don't need to do the other labs? No, but just realize this stuff is getting into more detail than what's really on the test. Is it bad for you? Definitely not. Is it more than you need? Definitely. But I just want to bring that up so that if you're doing labs and freaking out, don't freak out. Keep referring to this blueprint and what you really need to know to pass the test. Okay. Now, having said that, what I want to do now is I do want to talk with you about routing and about routing protocols, because one of the other items here is it talks about compare routing protocols, advanced distance vector versus link state, load balance, path selection, all of these, and these simple OSPF environments, including multiple normal areas. Okay. So I want to talk a little bit about those. I need to get down into here though and find all the stuff I want to do, but I want to discuss it. I don't want advanced BGP. I want the other one. Okay. Let me get my little pad here. Get my whiteboard up. Okay. So I want to talk about routing protocols. And in particular, I want us to do a quick overview of routing protocols. and I'm not actually going to use my favorite little thing, which is Notepad. I was talking about NAT and static NAT with my other class. But we're going to use my whiteboard here. And so, get pulled over. What are the two main types of routing protocols? So when we talk about routing protocols, there are two main types that they are broken into. And let's start with a very simple definition of a concept that you've heard of before. What is an autonomous system? If I asked you for a definition of autonomous system, what would you say?
It's going to be a system where an algorithm makes solutions and generates results.
Close. Close.
I would say a network of networks that you have control over.
Okay. It's typically, yep, a group of routers or a network under the control of a single admin. I noticed today, folks, how much my actual handwriting has changed since I've been injured. Of a single admin. And when I say single admin, I don't mean one person. I mean one administrative group. Okay. Running the same IGP. Oops, not RP. IGP. Okay. Now, that brings us.
Question.
Go ahead. Well,
Now, all the routers in that particular group that's going to be talking, they all have to be in the same group, right?
well, define group. They don't all have to be
Well,
in
they
the
get
same.
assigned a number, right?
Right. They got to be running the same interior gateway protocol. Now, that doesn't mean they got to be in the same area, because if it's OSPF, it can be multi-area.
Right,
They
right.
all have to be running the same interior gateway protocol.
Okay,
Now, it could be, here's the thing, an autonomous system could be 2 or 3 networks in 2 or 3 different cities, but they're all controlled by one group of administrators and they all run the same interior gateway protocol.
Okay.
So that's where we get this concept of an interior gateway protocol. Gateway protocol. And then, of course, if we have interior gateway protocols, then we have what?
exterior.
We have exterior gateway protocols. Now, exterior gateway protocols, man, I cannot write, y'all. I thought my handwriting was bad, but it's even worse than I thought. Exterior gateway protocols, there are only 2 that have ever been really talked about. That's an OLS, not protocols. There are only 2 exterior gateway protocols. One was a really old one that's never used anymore called EGP, which is literally exterior gateway protocol. And the other one is our little friend BGP. Okay. So EGPs run between autonomous systems. So AT&T, they have a large autonomous system they control. Comcast, a large autonomous system they control. BGP is the EGP used to connect Comcast to AT&T. It is the large exterior gateway routing protocol that keeps everything on the internet working. It's also considered to be what's called a path vector protocol, and we'll see what that means in a minute. It is a path vector protocol. Now, under IGP, let's list a couple of IGPs, but IGPs break down into 2 subgroups. Those 2 subgroups are, can anybody remember one of them? What are the 2?
Link state,
Link
OSPF.
state, yep, link state. So we'll put link state over
distance vector.
here. Yep,
Distance
link-
vector.
Yes, sir. Link state and distance vector. Distance vector over here. Okay. Now, these 2 are, then we've got different protocols that fall into these different groups. Name a distance vector routing protocol.
RIP.
RIP. All the versions of RIP, V1, V2, V1, V2, they're all distance vector routing protocols. Name another one.
Yeah, GRP.
EIGRP, even though it is considered by many and has been at one point in our curriculum, it was actually called a hybrid protocol. It's still a hybrid distance vector routing protocol. It's still a distance vector routing protocol. This also means IGRP was a distance vector routing protocol. All right. Now, what about link state? What are some link state protocols?
OSPF.
OSPF is the big one, and what else? It's really only one
ISIS.
other one. ISIS or ISIS is, okay? Which has actually kind of made a comeback. My understanding is ISIS has made a comeback since MPLS has been rolled out, or multi-protocol label switching, okay? But these different types, now remember, when we talk about a distance vector routing protocol, typically distance vector routing protocols have simpler metrics. They share their entire routing table at a predetermined interval, RIP every 30 seconds, etc. Now, there's where EIGRP is a little different because it does triggered updates and it does some things that are a little different, but it's still underneath a distance vector routing protocol. Link state typically has more complex algorithms. It uses more tables, more information, and usually link state, the routers have a better understanding of the topology of the network. What have you ever heard of the concept of routing by rumor? Routing by rumor.
Mm-mm.
Well, that's what is sometimes rumor talked about with distance vector, because in distance vector, the routers only talk to their directly connected neighbors. They don't talk to everybody. With a link state routing protocol, it's different. OSPF, it'll send out information, and it sends out information about its link states to everybody. It floods it out. That's why back when we discussed link state back in the CCNA, remember the concept of a DR and a BDR, so that we could reduce the number of adjacencies you had to create in a multi-access network? That's because that flooding that was taking place. All right. So these are two main types of protocols. You need to understand them. You need to understand how they work and where they're being worked. Now, let me ask you this. OSPF, what is the metric for OSPF?
Bandwidth.
It's bandwidth plus the sum of the delay, right? No, it's cost. It's
Right.
cost. OSPF is cost. EIGRP is bandwidth plus the sum of the delay. Now, having you said bandwidth plus the sum of all delays in the link. Okay, that's what that one is. You said bandwidth, and that is somewhat correct, because what is cost? The metric will be, if you're asked on the exam, what is the metric for OSPF? The answer is cost, but the cost is determined by the bandwidth of the link. So your answer actually wasn't incorrect. It was just, if you're asked on the exam, the bandwidth is cost based upon bandwidth. Okay.
Mhm.
Now, BGP. BGP is a totally different beast. Here's something else you're going to learn. Typically, to this day, in order for a routing protocol to put something in the routing table, it had to be accessible either as a connected route, or it had to be learned and known about from another routing source. BGP will do weird things. BGP will let you make stupid mistakes. Okay. BGP will let you route for things you don't really know about or don't really have a route for. BGP will also do stupid things like take 5 minutes for a route to update. I call BGP the coffee table protocol or coffee cup protocol. Make a change. If nothing happens, go get a cup of coffee, come back and check it. Okay. And there's a reason for that. There's a reason BGP is not designed to be super fast in making changes. We don't want people to be able to go on the internet and suddenly wipe out the internet BGP table. We want there to be checks and balances. We want there to be reasons. So that's why BGP can be very dangerous if we're not careful. Any questions about this overview of routing protocols? It's a very quick, simple overview. All right. let's look at BGP. Let's look at what BGP is and some of the basics of BGP. So it is the Border Gateway Protocol. It is the EGP of the internet. We're now on what version? BGP version
I think
Four.
4.
version 4. We're running 4. So it is designed to route between autonomous systems, which are collection of routers under the single organization's control using one or more IBGPs or IGPs. So one or more IGPs. Typically, they run the same IGP, but it can be more than one. That typically only happens though when an organization, for whatever reason, has bought another organization and one part's running one IGP and one's running another. They usually try to keep them the same. Either way, autonomous system numbers can actually be assigned from INA, and those are true autonomous system numbers. If you've ever done or configured EIGRP, you know the command is EIGRP and then autonomous system number, right?
Yeah.
It's not really an autonomous system number though. It's really just a process ID.
Process number.
Yeah, it's just a process number to hold that particular process in memory. You're not really putting a true autonomous system number there. With BGP, you can be placing a true INA assigned autonomous system number, okay? Now, if you're going to get one, you've got to prove that you have a publicly allocated network range, that you need it, and that you have multiple internet connections. If all you ever have is a single connection to the internet, you will never, okay, I won't say never, you should never need BGP, okay? Because you've only got one route out to your ISP. But where we get networks that desperately need BGP are when we have networks like this. When we have, here's our internal network, and we've got a router on the edge, a router on the edge. These come into some kind of switch here. Okay, there's a switch here that they're connected to. All right, and this goes to ISP1. This one goes to ISP2. This is called a dual home network. Okay. When you're running this, typically you need some type of, you need to run BGP because there's got to be a way to control what traffic goes out this way. And you can do it with other things, but BGP is a good one, and what traffic comes back in. The other thing is you need to be able to control when this goes down, traffic that had went out this way needs to find its way back into your network this way. So if you're dual homed, you're more than likely going to run or need to run BGP. Not always, but more than likely. We, by the way, when we recently did a redesign on our network, we went to a dual homed setup to be the 2 different ISPs. Those ISPs, we did have to actually set up BGP. One thing I'll warn you about in the real world is make sure these 2 ISPs you're connecting to are not connected into a third ISP up here, and they're totally relying on that ISP, because then you're really paying for no redundancy at all. So make sure your upstream ISPs are truly separate from each other. Otherwise, you're going to end up with this ISP3 going down and your network's down, even though you're paying for all this connectivity to ISP1, ISP2. All right. So you see our numbers here, 65,512 to 65,535 are private. So you can actually use those if you're wanting to do your own private ASNs. Then they've also got those from INA that are individuals. They're going to be out 294 million plus ASNs. That's because they've expanded it from 2 bytes to 4 bytes. So it's a bunch. We do have inside of BGP these different types of path attributes. Now, let me see if I want to go here first before I talk about the path attributes. We describe BGP as a path vector protocol. What it does is it actually keeps up with all the autonomous systems that your traffic passes through. If at any time it sees its own autonomous system number in a route, it will block that because it thinks it's a loop. So it will behave like a distance vector protocol to ensure there is no loops. by making sure its autonomous system number is not part of any route. So this would stop the loop. Now, part of that is done through what are called path attributes. And so each network path, each one of these hops are mapped or associated with certain well-known attributes. Some of them are well-known mandatory. They're well-known and they must be in every single update. Well-known discretionary, they're well-known. They don't have to be in every update, but they can be. Then you've got optional transitive, which means they're not normally implemented, but if they are, they must be carried by all updates and they must be moved along with this update. And an optional non-transitive is an optional one that does not have to be carried by other BGP entities. So if it's well-known mandatory, it must be included in every single prefix advertisement, regardless. If it's well-known discretionary, it may or may not be included. So we'll talk more about those as we move forward. BGP is multi-protocol capable. It can do both IPv4 and IPv6, no problem. It does have the attributes multi-protocol reach, network reachability. Those are all there. It does not use hello packets to discover neighbors like IGP protocols do. It cannot discover neighbors automatically. You have to set neighbor statements, and they're defined by IP addresses. You need to know that BGP uses TCP port 179. I've seen over the years certification questions that talked about you're trying to implement BGP and you cannot get your neighbor relationships to be established. Why is that the problem? What is the problem? And you'll dig down in all these configurations. Okay, Larry, I'll check that one. Yeah, 612. Is that
Yes,
on CML or on NetLabs?
NetLabs.
Okay, I'll check it. And by the way, I don't know if Philip's here, but Philip's been doing some of them in CML and they're working pretty well too, but I'll check it. Yeah. Will you do me a big favor, Larry? Will you email that to me also? So I can
Okay.
check it? Please do. And I will check it. Yeah.
All right.
But I've seen questions like that that said you've got you look through all your setup and all your BGP setup is correct. And what is wrong is there's an access control list blocking TCP. And if you can't establish TCP connectivity, BGP will not work. Okay. Here's the other thing. Unlike IGPs, it can form adjacencies of routers that are multiple hops away. So in other words, you have a BGP router here and a BGP router 3 hops over. Those two can be neighbors with one another, even though they're not directly connected. So it can do some really, really weird stuff. Now that's multi-hop and it gets some weird things. I mean, that is real weird configuration, but you can do it.
Is that done dynamically or do you have to statically create that?
You have to statically create it. Yeah, you have to, you
Okay.
must set that relationship as a neighbor relationship. Yeah.
Okay.
Not dynamic. So here we see here BGP peering. So this is an example of I would have taken and created a neighbor statement from R1 to be a neighbor with R2, and R2 was a neighbor with R4. Now the important thing is this. There has to be some way for R2 to get to R4 to establish this BGP peering, this multi-hop BGP. A default route won't do it. Now it could be a static route, or it could be what happens many times is actually there's an interior gateway protocol being run, and that's how it learns the route to get to its BGP peer. Which is confusing, but just be aware that is part of BGP, that you can use an IGP to establish the TCP connectivity to do your BGP peering. Okay. Now, BGP comes in 2 main types, iBGP and eBGP. iBGP are routers in the same AS that participate together, okay, or in the same federation. Federation is a group of ASs that are joined together. So iBGP, you'll notice, has an AD of 200. Now that, folks, is a pretty high administrative distance in the RIB. Think about that. I don't know of any routing protocol, any IGP that has an AD of greater than 200. There's maybe 1 or 2 subforms of eIGRP I can't even remember. I can't think of anything off the top of my head that's over 200. eBGP are sessions that are in different ASs. Now, what we're going to do for this class, remember, is mostly eBGP between directly connected neighbors. So we don't even have to worry about multi-hop eBGP. We're only worried about directly connected neighbors. But be aware it is possible. So iBGP lets you do transit connectivity. Enterprises should not be a transit. You have to be very careful with iBGP because you never want to become, unless you're an ISP, you don't ever want to become a transit setup. Let me show you why. Imagine this network right here, and imagine, heaven forbid, okay, you mess up your configuration. And let's just say that for whatever reason, all this is not, this is just the internet out here, okay? And you mess up your configuration and you turn your network into what's called a transit. Well, if you do that, what's going to happen now is traffic from the internet can come in and be routed through you. You've just made yourself into an ISP. Transit ASs should only be ISPs, not you. So you had to, the configuration, you had to be extremely careful with configuration of BGP, because if you make yourself into a transit, it's really, really bad, okay? For instance, you could accidentally have 780,000 prefixes. It's actually over 800,000 now. You could have 800 different prefixes that will be downloaded into your BGP config. How many of the routers on most networks could handle 800,000 routes in their route table? Very few, almost none, unless they're ISP rated. Oh, no problem, Naval. Go ahead. No problem at all. Go ahead and jump out if you got your class. Okay. So be aware of that. The big thing about iBGP is that you can actually use IGPs or interior gateway protocols to get a full mesh, so you can do proper forwarding. We'll talk more about that later, especially as we get into ENA RSI if you take that class with me. So eBGP Core Component. It allows for multi-hop sessions. It sets the TTL to 1, so packets are dropped if there's a multi-hop. iBGP allows for multi-hop. eBGP does not. So eBGP will not allow you to become a transit unless you actually literally tell it to. The other thing you'll learn about is the network reachability, and you will learn about these 4 packet types here: open, update, notification, keep, or OINK. That's how I remember for BGP, OINK, O-U-N-K, OINK. Open packets, open, set up and establish the BGP adjacency based upon your neighbor statements. Updates, advertise, update or withdraw routes. Notifications will give you an error message, and keep alive, ensure the neighbors are still alive. So OINK, that's how you remember the 4 packet types in BGP. Our neighbor states, once we start a BGP session, an eBGP session, is idle. Actually, either eBGP or iBGP, we go through the same stage, but idle, connect. We've got open sent, so we've sent a source packet to the remote AS. We've got a reply, a confirm, then keep alive. And once we get to established, it's only at the end of the established that we actually start sending our BGP tables. If you accidentally had a one-way setup where information can only travel one way at once, you could get stuck in the open sent area and never get to established. So if your BGP session is not established, you cannot share your BGP tables. So this TCP session with its peer uses this finite state machine. So the first is idle. So it's detecting BGP to start, initiates TCP with a handshake, does connect timer, moves to active, starts another 3-way handshake, goes to open sent, open confirm, and established. Everything's good, and we can now send our update messages. Okay. So let's real quickly, we're running out of time. Let's look at basic BGP configuration. Initiate the BGP process with the command router BGP AS number. Now, in this case, the AS number is truly an AS number. Now, it could be a private AS, which is what we use in most of our labs, but in the real world, it's probably going to be an ASN or an actual autonomous system number you have received from INA or your ISP has gotten for you from INA. You're then going to statically define the BGP router ID, which is just like our OSPF router ID. Very similar. You set a router ID so that it's always up and available in case interfaces go down. Then you're going to set your neighbors using the command neighbor, the IP address of the neighbor, and the remote neighbor's AS, and then do the same thing on the other side. Now, if you're using different, this is called address family and sub address family identifiers. If you're using multi-protocol BGP, you may set up IPv4 and IPv6 address families. And then you can actually set up an address family and activate it using this command, neighbor IP address activate. So let's look at a very simple configuration. Here we are setting up router BGP 61500. So that's R1's autonomous system number, connecting to neighbor at 10.12.1.2 remote 65200. And we're going to say that the neighbor on R2, the default IPv4 address is enabled. So in other words, this says R1 is set up to allow IPv4 by default. So they haven't turned it off. In R2, they've disabled the default address family and have set it up using this command. So this is address family IPv4, neighbor activate, exit. So this basically says, I am going to be a neighbor with this remote AS using IPv4. On router 1, we were using a default configuration where we're not using address families. Both of these accomplish the same things. And we could actually use the same configuration on R1 as we did on R2 here. Okay. Questions? Anybody have a question on that? If we were doing IPv6, by the way, it'd be address family IPv6. And we would do a neighbor IPv6 address activate. Verified show BGP address family, sub address family summary. If you want to do this, so it's show BGP IPv4 unicast summary. So this is the address family IPv4. The sub address family is unicast. And this tells you that I have a neighbor 10.12.1.2 version 4. It's autonomous system 65200. This is the number of messages sent and received. How long it's been up or down, up, down. So it's been up for 5 hours or 5 minutes, 23 seconds. Okay. Typically, message received and sent should be pretty close to each other, depending on what's going on there. But you'll notice that network statements do not enable BGP for a specific interface. They identify network prefixes to be installed in the what's called the local routing information base. As it is installed in the local RIB, the BGP parameters are set, whether or not it's a connected, okay, so it's a connected network that is on the local machine, or is it a network that is known via a static route or some other interior gateway protocol, which changes the weight and changes the attributes of a route. Okay. So you'll notice in order to be placed into the local RIB and advertised, it must pass a validity check. It verifies that the network reachability is valid. The next top address is resolvable in the global routing information base. If that fails, it will not go any further. In other words, like most routing protocols, you have to have a way to get to the network. But to this point, all of our routing protocols have only been able to advertise networks they were directly connected to, not networks they had learned from another router. So in other words, you couldn't put a network statement on a device for a network that wasn't directly connected. In BGP, you can do that if it is learned through a static route or another interior gateway routing protocol, as long as the network reachability information is in the RIB. So not in the routing information base, there's some way for a BGP router to get to the network you can advertise it into BGP. That's different than our other routing protocols. Our other routing protocols have been, you must have a route that is directly connected in order to advertise it with a network statement. Does that make sense? Can you see
Yeah.
how that's different than our other routing protocols? Can you also see how powerful yet dangerous that is? Because you could very quickly start sending out information about networks that you don't fully control and you don't have the best pass to. So BGP is a dangerous little protocol, but if it passes that, then it can go into the adjacency rib out and it can go out as a route to the peers in BGP. So here's our network statements. Again, network 192.168.2.2 mask. Notice it uses a subnet mask, not a wildcard mask. It is a subnet mask. And there's other ways you can also do things using route maps and others, but you can put in just a regular network in 10.12.1.0 mask, and that tells it's going to advertise that particular network, the 10.12.1.0 network. This is basically saying this is the IP address of the host, and it wants to advertise that one address for some reason. And then 3 tables for maintaining that prefix, and that is the adjacency rib in contains the network layer reachability information in its original form. The loc rib contains the network layer reachability information that was originally or locally received from other BGP peers, and the rib out contains the network layer reachability information after the outbound route policies have been processed. So those outbound processes or route policies are things we will learn about later called route maps or distribute list, ways to say, yeah, don't advertise this one network inside of this group of networks using an outbound route policy. So we can do a show BGP AFI SAFE, so basically address family, sub-address family, and you can see all the different routes in the BGP routing table. Okay. And folks, I'm actually going to stop here because we're at 5:52. Are there any questions about basic BGP? This particular section here with the route summarization, all that piece of BGP I just showed you is what you need to know, along with the information about the attributes that we'll talk about next class. The attributes, those are the things you need to know for the test and to be able to get through the CCNP Encore. Okay. Any questions?
We have the video up later because I got here
Yeah, I'll
late.
definitely have it up later. I'll have it up in probably next 15-20 minutes, just whatever it takes me to get it to be able to be set up. So
Okay.
yeah. So I'm going to stop.